Hi 47. Okay, I'm back. So now we are going through question 36 of your practice paper 1. Okay, maybe the teacher can pause this video so that they can search for their practice paper. Okay, question 36. Nigel compared two similar containers containing marbles and water each. So what is the state of the marbles? What is the state of matter of the water? Okay, this is a very simple and direct question. Okay, so marbles, definitely state of matter, solid, liquid or gas? Solid. Okay, next, water, you know it's a liquid. Okay, so these two are giveaways. State a difference between the properties of the two states mentioned in A. So what is the difference in the property of a solid and a liquid? So what is the difference in the property? So over here, it's the difference in between the properties of the two states mentioned. Okay, so the first difference, okay, I think there's only like one difference here. Okay, when we talk about properties, we are talking about shape, we're talking about volume, we're talking about compressibility. Okay, maybe I can write down here. We're talking about the volume, we talk about the shape, we talk about the compressibility of the matter. Okay, and the difference between a solid and a liquid is shape. Alright, so solid has a definite shape, but liquid has no definite shape. So that would be the difference, and that will be 1 mark. You have to compare. What about volume? Both solid and liquids have definite volume. Alright? And both solid and liquids cannot be compressed. So there are two similarities between solids and liquids, and there is one difference, which is the shape. Right. So teacher, if the class needs to copy down the notes, please pause the video for them to copy down the notes before continuing. Okay, let's look at part C. Nigel filled a syringe with some sponge and tried to push the plunger as shown in the diagram below. He managed to push the plunger in slightly. You see the word push, 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 push. So what property do you think this question is asking you about? Compressibility, right? Okay, so we have to gather clues from the question stem itself, alright? So you see the word push. Alright, you relate it to the compressibility. Okay, and you see the word sponge. See the word sponge. Sponge is a solid with holes, right? And what is in the holes? It's holes that are filled with air, right? Solid with holes filled with air. Now, in this case, when we talk about being able to be compressed, when Nigel is able to push the plunger in, when Nigel is able to compress the sponge, is Nigel compressing the solid, or is Nigel compressing the air in the holes of the sponge? Think about the properties of solid and air, right? So solid cannot be compressed, but air or gas can be compressed. Right, so we make use of that. So explain why Nigel is able to push the plunger in slightly. So we must mention about the air present in the sponge. There was some air present in the sponge, and that would be half a mark. Okay? Now, this is just half a mark. Where does the other half a mark? How do we get the other half a mark? Okay, it is to use the science concept. Which property of air allows it to be pushed? Alright, it allows it to be pushed. Alright, so in this case, you say air can be compressed. So that will be half a mark. So Nigel would push in the plunger slightly. Alright, so first identify what is present in the sponge, then you talk about the property that allows Nigel to push in the plunger slightly. Okay, I think there's quite a bit that you have to copy down. Okay, some of you mentioned that air can be compressed, but I did not state that there is air present in the sponge. Where some of you mentioned that there's air present, but so what? You know, you have to answer the question. So what if there is air? So how does it lead to Nigel being able to push the plunger? So you have to explain in full. Alright, so let's move on. Nigel replaced the sponge completely with water. Just now we mentioned that water is a liquid. He was unable to push the plunger. Explain why this happened. So same thing again, is about compressibility. So when we link compressibility with liquid, what can we recall? Liquid cannot be compressed, right? So why this happened is because liquid cannot be compressed. Or you can say water cannot be compressed. Okay, that will be 1 mark. Is that clear? Or you can even be, more specific in your answer. You can say water is a liquid and liquid cannot be compressed. Alright? I do not really like the answer water cannot be compressed. So what state of matter is water in? Alright? So let's move on. Jasmine set up the experiment below to magnetize an iron nail. So this setup is actually using the electricity to convert a magnetic object like an iron nail into a magnet. So we mentioned in our previous lesson that this method of using electricity to make a magnet, okay, it is temporary. Okay, let me just move this here. Okay, so iron nail is a magnetic material, so able to be magnetized, alright, to become a magnet. And I would like to also write this down. This is okay, so the iron nail will become an electromagnet. Alright, the iron nail will become an electromagnet. And this method is temporary. it becomes a temporary magnet, which means that if I break the circuit, which means that if let's say the batteries are not connected properly, okay, the wire is not connected properly, okay, the electricity is not flowing smoothly, the iron nail will no longer be a magnet immediately. Alright, so it's a temporary magnet. Okay, name Jasmine's method of making a magnet. Okay, what is this method called? Okay, it is using electricity to make an electromagnet. Okay. There are also some answers that I see in the answer key, which I don't really like the answers. They say, oh, it's called the electro method. No. Electronic. No. Electric method. Maybe the best answer will be using electricity to make an electromagnet. Alright? Okay, part B. Jasmine placed some paper clips near her temporary magnet. It attracted 4 paper clips. Suggest 2 ways Jasmine could change her setup so that the temporary magnet can attract more paper clips. Okay, remember the previous experiment we did in the science room? Okay, so we changed 2 variables. Okay, for the first round, okay, we actually changed the number of batteries, right? Then for the second round, we changed the number of coils around the magnetic material. Okay, so in this case, how can we attract more paper clips? Okay, first way is to add more batteries. Or you can say use stronger batteries. Okay, so one of the method is about the batteries. Okay. And the second method is about the coils. Add more coils or turns around the iron nail. Right? So the second method is about the coils. Okay, teacher, if you need to, you can pause the video so that the students can copy down their workings and their answers. Okay, part C. Jasmine noticed that the door stopper below stopped the door from closing. Okay, very common kind of question. Okay, how do you relate science concepts to our everyday life? So I believe most of you will have this door stopper at home, and you realize that part of this door stopper is made of metal. Alright? So, explain how the door stopper was able to keep the door from closing. How does it keep the door from closing? So what topic is this? This is part of the magnet topic, right? So you think about magnets, you think about the north and south pole. So if you want to prevent the door from closing, you want to hold the door in place, right? Okay, so there must be some form of attraction. There must be some form of attraction. So I would need to see the word attract. Okay, attract. Attract is a science word. Okay, do not use the word stuck to each other, stick to each other. All these are not science words. Science words are like attract, repel. Okay, so we say the magnet on the door stopper attracts the metal attachment on the door. So that will be the answer. Maybe I should put it longer. Let me see. Okay. Alright? So you do not have to say that the metal attachment is a magnet. Okay? It can be a magnetic material, because in this case you only want attraction. Okay, so metals are not metals. Magnetic material and magnets, they are able to attract each other. Okay, that will keep the door from closing. Okay, let's move on. Lisa collected 3 different samples of water and placed them in separate beakers. She wanted to find out which sample of water was the clearest. She held each beaker under a torchlight and placed a sheet of paper below the water sample, as shown in the diagram below. So torchlight is your light source. Okay, and you change your water sample. Alright, your changed variable is your water sample. The rest should remain the same. And what is the paper? The paper acts as a screen. Okay, a screen. Paper acts as a screen. Okay, because the image will be formed on the paper. So, what did she observe? She observed and recorded the amount of light that fell on the sheet of paper with each sample of water. So for X, she observed that a bright patch of light was seen. This meant that the water sample allows most light to pass through. Am I right? It allows most light to pass through. Okay, so we write here allows most light to pass through. That will be for X. What about Y? No light is seen on the paper. Okay, you shine the light on the water sample, but no light passes through. That's why no light is seen. Okay, does not allow light to pass through. Okay, what about Z? A dim patch of light. That means some light can still pass through. Okay, some light can pass through. Which sample of water is the clearest? Obviously, it will be the one that allows most light to pass through. Okay, so answer will be X. Give a reason. It allows the most amount of light to pass through. Take note. Okay, I'm going to write this down, and I think I repeated it many times, millions of times. Okay, see the word clearest. Okay, means you are comparing. And how many objects are comparing? More than 2, right? So, when we compare, we must use the word most light. Okay, we have to compare it, the amount of light that passes through. X allows the most amount of light to pass through. Okay, let's move on. To ensure a fair test, the beakers used must be made of the same material. Name 2 other variables that have to be kept constant. Now, what is the changed variable here? What is the changed variable? The changed variable would be the water sample. So the rest should be kept constant. Okay, so what should be kept constant? For example, the distance between the torch and the beaker, the distance between the beaker and the paper, the distance between the torch and the paper, the amount of water in the beaker, the brightness of the torchlight, the size of the beaker, the material of the beaker, the depth of the water, the type of torchlight, the power of torchlight, and lastly, to hold the torchlight at the same place. Okay, so I'm going to write down all the answers here. Okay. Hopefully, I'll manage to write down everything. Okay. Okay, so we can talk about the distance between between A, the torch and the beaker, B, beaker and paper, C, torch and the paper. Alright, or you can also talk about amount of water in the beaker, brightness of the torchlight, size of the beaker, material of the beaker, depth of the water, type of torchlight, power of torchlight, hold the torchlight at the same place. Alright? Teacher, can you pause the video so that the students will be able to check whether they have the correct answers and to copy down their corrections? Okay, just to mention something about part A. Some of you said X because there is a bright patch of light. Okay, so what can you infer when there is a bright patch of light? What is the meaning of clearest? Clearest means allowing the most light to pass through. Okay, so you cannot just plug whatever that you see on your table into your answer. Sometimes you have to make some conclusions about it and you explain it using science concepts in your question. Alright? Okay, next move on. Sam used a torch to shine on a tennis ball as shown. A shadow of the tennis ball was formed. Draw the shadow that is formed on the screen in the box below. Okay, take note. Take note. A lot of you got this question wrong. That means totally A, B, 0. You know why? You have to look at where the tennis ball is placed. The tennis ball is placed at the bottom of the screen. If the tennis ball is placed at the bottom of the screen, how come many of you do your shadow to be in the middle, at the top, nowhere near the bottom of the screen? Okay, so that is wrong. Okay, so let me just let me just open up. Copy. See whether I can paste. Paste. No. No. Paste. Oh no. Give me a while. Cut. Okay, so no, I still can't. Okay, let me see if I can. Yeah, definitely I can draw a circle. But the problem is I can't shade it. I do not know how to shade it using this. How do I shade this? Ayo. Okay, let me see. Can I draw? Okay, let me see if I can draw. Hey, no. No. What happened? Ayo. Okay. Oh well, just listen. Okay, you have to shade. Shade your shadow fully. Alright, because shadow is formed when light is blocked, right? Okay, you do not have transparent shadow. Alright, so I cannot shade, but you're supposed to shade. Alright, please shade, shade. Okay, next. Sam placed a cardboard box as shown. Okay, draw the shadow that is formed. Okay, now. There are two possible shadows. Alright? So, the first assumption is when the ball has a greater width than the box. Okay, that's my first assumption. Okay, my first assumption is when the ball has a greater width than the box. Okay, so your shadow will look different from the second assumption. The ball has a smaller width than the box. Okay, so there are two assumptions here. Okay, I'm going to draw the first one. Okay. Layout blank. Okay, so I'm going to insert a table. Okay, when ball has a greater width than the box. Okay, when ball has a smaller width than the box. Okay, so it looks something like this. Insert shapes. Okay, let me try to get this correct. Okay. Okay, this will be the This will be when the ball has a greater width than the box. Okay, and when the ball has a smaller width than the box, it will just, the shadow cast will just be the shadow of the box. Alright, and if let's say this is your screen, okay, if let's say this is your screen, your shadow must be at the bottom of the screen. Okay, so take note. Shadow must be at the bottom of the screen. Okay, like the position of the objects. Alright, so teacher, please freeze if the students need to copy down the answers. Thank you. Okay, let's move on. Sam measured the height of the shadow form on the screen as he moved the torch towards the tennis ball. What happens to the height of the shadow on the screen when the distance between the torch and the tennis ball decreases? So basically, they want you to form a relationship between the left column and the right column. So it's very simple. So what is the relationship between the left column and the right column? So answer would be, okay, let me change the color. Okay, the height of the shadow increases. Okay, or you can say taller, becomes taller. Okay, do not accept bigger. Why? I do not accept bigger because it is an increase, can be an increase in width. Okay, so I do not accept bigger. Alright, next, what should Sam do to decrease the height of the shadow form? If you want to decrease the height of the shadow form, okay, look at the relationship here. So you want to decrease the height of shadow. So when you decrease from 8 cm of your height to 3 cm of your height of the shadow, okay, look at the distance between the torch and the tennis ball. From 2 cm to 8 cm. So what should he do? He should increase the distance between the torch and the ball. So this is based on the table. Alright, so this is based on the table. Okay, of course, there are also other answers. Okay, you can say move the ball further away from the torch. Okay, or you can say increase the distance between the torch and the screen. Okay, lastly, you can say put the ball closer to the screen. So there are 4 possible answers. Okay, 4 possible answers. Is that okay? Okay, you don't have to copy everything. Okay, remember the method I told you about. So you can move your hand. Your hand is your object. Okay, the classroom lights will be your light source and your table can act as your screen. Okay, you can use that to actually determine how to make the size of the height of the shadow, how to decrease the height of the shadow. Okay, you can use that. Okay, make use of your hand, the classroom lights, and your table. Okay, if not, you can put a piece of paper on the table and that can be your screen. Okay, move on. Okay, question 40 I've already gone through. Okay, question 40 I've already gone through, as well as question 41. Okay, once you're done, can you please submit your papers to the relief teacher? Okay, complete your corrections properly. Is that clear? Okay, once you're done, you submit. Okay. Okay, thank you. This is all for the science lesson. Have a great day. Goodbye.